Hiya, it's Ftrhstry. Looking at the 2020s from the 2120s, I'm Kingdangerously. This is my time vortex. Welcome. I'm here to talk to you today about the James Webb Space Telescope. What is it? Why is it in the sky? Why am I excited? What can it do? Does it matter anymore? What does it bring us in the grand scope of scientific inquiry? Why should I care? And what can I tell my friends or potential love interests? Here's what you might tell them. You might tell them that the James Webb Space Telescope, aka Webb, aka JWST, is replacing, augmenting, gently upstaging the Hubble Space Telescope, which is a super cool piece of technology that's been up there for in the 2020s, like 30 years, capturing some of the absolutely most iconic images, which you've just got to find. If you've never seen Pillars of Creation, for example, the one with all the dust clouds reaching up to infinity, asking, is there a beyond? What would it be a beyond from or to? Oh my gosh, it's so good. Another one that's just fantastic is the Sea of Galaxies, just like they pointed it at empty space for 100 straight hours. This one scientist had to convince them all to do it. He said, I promise I'll retire if I'm wrong, but I think this will be cool. They were like, all right, I guess we'll do it, but you're off, Jim, if you're wrong. And he was so right. Such a cool picture. It's like thousands of galaxies just all bundled up in this little box of otherwise complete blackness, because space, blackness, the blackness of space is actually an illusion. It's quite bright out there, but all the light is coming from very far away, and it's coming through stuff, so it's hard to see. And that's one of the main reasons that the James Webb Space Telescope, bit of a clunker, that the Webb is using an infrared camera among several of its cameras. So the main camera is, what is it called? It's a near infrared camera, and that's going to sort of peer through the mists of the cloudy stuff like in the Pillars of Creation, because infrared waves are wider than visual waves from a light perspective, so they can actually get through some of that physical obstruction that's out there in space. There's just dust, like if you see the Milky Way on a really good night, you can see sort of cloudy, floaty stuff, and the infrared waves, the heat signatures of the stuff behind it are going to pop through, and that's going to allow the Webb to get all the way back to like pretty close to Big Bang days, like a couple 100 million years after the Big Bang, which is of course nothing in cosmological time. That's why, some people are excited about the time machine aspects. I mean, whoop-dee, no, it's not a time machine. It's not actually traveling back in time. It's just that light is very old, which means we're looking at stuff that's already gone from our ability to interact with in the future, even the far future, accepting some really bendy space stuff that's only a maybe. In some timelines, wormholes are a possibility. We'll get to that in just a moment. What else have you got to know? The Webb is going to look for exoplanets, so it's going to be much better than anything we have currently at detecting signatures of like chemical composition and mass of exoplanets. So we're going to be able to guess at like, is there hydrogen in the atmosphere? Has this planet got water on it? Stuff like that. Pretty cool, obviously. And we're going to get some like actually almost picture-y type stuff of these exoplanets, which is like really cool. I mean, so far it's just sort of like dips in light, and that's the best we've got. A lot of these things are very far away. The closest exoplanets, Alpha Centauri, 4.5 light years away. Then there are some in like the 10 light year range, but like the very closest galaxy is 25,000 light years away from the Milky Way. So it's just it's a bit too long for interactivity, which we'll talk about also in the coda as we get to the more future-y stuff. What else have you got to know? Oh yeah, here's a cool one. The Hubble Space Telescope, which is named, by the way, for the progenitor of the musician who wrote the stuff you're listening to right now. Let's just let it sing. Gosh, it's beautiful, isn't it? And that, you can thank John Hubble for that, and the line of handsome, talented Hubble geniuses. So the Hubble's pretty close to Earth. It's like 340 miles away. And it's orbiting Earth, but the Webb is going to orbit the Sun at L2, Lagrange point 2, which means it's going to sort of tuck around with the Earth as the Earth goes around the Sun, and at varying times it will be closer to or farther from the Earth, but it's going to range from up to almost 1 million miles, 200,000 to 900,000+ miles away from Earth, which is at the furthest, about 4 times the distance of the Moon. Coincidentally, the infrared signature stuff on Webb is able to detect a heat signature the size of a bee at about the distance of Earth's moon from Earth, which I just think is pretty neat. I mean, of course, it's adorable, childish garbage compared to the fancy stuff from the 2120s where I'm from, but back in the 2020s it's really fly. So you will no doubt be impressed, and the Webb is ostensibly going to be in service for like 5 to 10 years. It ends up being a little bit longer than that. There's some augmentative stuff that we can do, but in the 2030s and the 2040s it does get overtaken by a next generation of even bigger, wackier space telescopes. Ooh, already 6 minutes. Trip. What else is cool about the Webb? It's got a big gold mirror. It's that's sort of divided into hexagons, which fold up into the Ariane rocket for launch, and then will unfold to capture light. And this gold mirror, it's actually made of beryllium, to handle extreme cold. So the whole thing's got to be quite chilly, like more than -300 Fahrenheit, and in some specific circumstances as low as -450. They've got a cryo cooler on this thing, which is pretty cool, and that's for the mid-infrared spectrometer. That's a local planet photographer, which is going to be great. You're going to get rings from some of the other planets that you haven't seen them on, like Saturn and Neptune. You've seen the Jupiter rings, obviously, but you're going to get even better stuff than you've ever had in terms of visualization. Pretty pickies of the local asteroid fauna, like some Kuiper Belt objects. So, the big news is we're going to get a lot of good pictures. I mean, you have already gotten a lot of huge pictures, depending on where in the time vortex you're absorbing this information. And looking up what to Google on NASA, it's the size of a big house. It's got 4 different lenses. Sort of a super main big one, and then a little one, and then 2 curved ones. It's got some like really fancy instruments, the NIRCam, the NIR spectrographer, which is going to be able to detect the more physical qualities of the exoplanets. Sorry, just checking the clock, only a couple more minutes to go. And it's got a fine guidance sensor, which picks up its location in space 16 times a second. So that's, pretty good, and that helps it finely coordinate all of its bits and bobs. It's got to be a finely tuned machine because it's too far to repair for quite some time. So where is all this going? How does it fit into the bigger space future picture? Got about a minute to cover that. 3 things to tell you about space 100 years from now. 1, we're very into probes. We like the telescope, but we like them to be expanding. 2, these probes are returning so much data that it has to be sort of coalesced into basically world form, like these metaverses of information that are so wide and humongous and detailed that some intelligences actually populate them and like just permanently live there, and then some intelligences aspire to sort of encompass them. What is a mind really outside of what it understands? More on that in a future episode. And finally, the aliens. This is going to be the kind of technology that starts conversations with those places 5, 10, 15, 20 light years away. When you get up into the range of like 1,000 light years, it's just outside the space of conversation speed, and you have to get to actual probes. But we're going to find evidence of life, and we're going to find evidence of intelligent life over the next 100 years using fancy schmancy technology like this beautiful telescope. I hope you'll learn more about it and consider Googling the pictures or creating some yourself. Maybe you'll make some space art. Maybe one day you too can be coated in a 100 nanometer sheet of gold. All right. Love the future. Hope you enjoy space. I'm thinking about you with a lot of space in my heart tonight. It's raining. I'll go out with a bit of pat.